Hey everyone, welcome to our channel Physics, where we actually learn physics. So in this lecture we are going to talk about how exactly do we measure lengths. Also we will talk about what are the different kinds of lengths that we generally come across in research or in any science experiments that we do. Also we'll talk about what are the different instruments that we generally use for measuring different kinds of lengths. Okay. So this lecture is just going to be a little review about how exactly all these things happen, how do we exactly do it, what are the different instruments that we use, etc, etc. Okay. Definitely this video is not going to be a detailed video about all the instruments that we use, because we have few more videos coming up in which we are going to talk about all the methods, all the instruments which are used actually to measure different kinds of lengths. Okay, so just stay tuned. You are gonna see all those videos in the same playlist over here. Okay, so over here this is just a review about how exactly lengths are measured, what are the different kinds of lengths, what are the different instruments that we use, etc. Okay, so without wasting any time, let's start with our lecture and let's see what are the different kinds of lengths, what are the different methods. Okay, so let's start. So first of all, let's see what are the different kinds of lengths that we generally come across. Okay, actually there are three types of lengths that we generally come across. I am saying according to the human being, there are three kinds of lengths that we generally come across. Human being, okay, not according to anyone else. Okay, why I'm saying this? Because everything is relative actually. Okay, everything is relative. That means relative to a human being, okay, relative to any other animal, something is different, isn't it? For example, relative to me, okay, relative to me, this pen is small. Okay, relative to me, this pen is small, but relative to some mosquito, some ant, this pen is a very big, isn't it? Isn't it? This is very big in comparison to an ant or any mosquito, isn't it? Just an example, but relative to me, this is very big. So in this lecture, the three types I am going to tell you, they are relative to a human being, a normal human being. Okay, yes. So let's start. So over here there are three kinds of lengths that we generally come across. I will write here. The three types are very simple. Okay, the first one being nothing but, you know, the very large distances. Okay, very large distances. I will elaborate, don't worry. The second being very small distances. Okay, and the third one being the moderate ones or the average ones. Okay, so first one is a very large distances. Now what do you mean by very large distances? Like for example, with respect to us, the size of the earth, isn't it very large? Okay, the diameter of the earth, it's very large. The distance from the earth to the moon, isn't it very large? It's very long distance, isn't it? The distance from the earth to the sun, the size of the moon, the size of the sun, the distances to the stars, these are pretty big distances, isn't it? Isn't it? They are very, very, very big distances, very large distances. So such a distances can be called as a large distances. Then second is a very small distances. Okay, very small distance. What do you mean by very small? For example, imagine you have a paper in your hand right now. For example, you have a paper in your hands. Okay, so just check out what is the thickness of that page. Just check out what is the thickness. It's very, very, very thin, isn't it? The page that you can see is very thin. Can you measure that thickness through your naked eyes directly? Can you approximate that? Can you? Definitely you cannot. Okay, you cannot approximate the thickness of that paper directly with your naked eyes, isn't it? That's very difficult, isn't it? Okay, because it is very, very, very thin. Okay, imagine the size or the diameter of your hairs. You know, the single hair that you, yeah, that you can take. It's very thin. You cannot actually find out its diameter. Okay, so it's very, very, very small, isn't it? So such a sizes can be considered as very small distances. Okay, such a distances can be called as very, very small distances. Okay, so such a distances cannot be found out using the naked eyes or any other instruments like our scales. You know, we have our scales. We can't do that. Okay, so it's very difficult. Okay, so we need to use some other instruments, some other equipments for that purpose. I will talk about that. Third one is this, the moderate distances. Now the name itself suggests the moderate ones, the distances which can be measured using our normal meter scales. Okay, which can be measured using our normal meter scales. So these are called as moderate distances. Okay, so let's talk about each one of them first. So first I will talk about this moderate distance. Okay, so the name itself suggests it's a moderate distance. Okay, so generally we have our scales. You know, we have these scales over here like this. Okay, generally we have it in our bags. We have it in our compass box, something like that, pouch maybe. We have it all the time. Okay, everywhere since our childhood. We have been having that scale, isn't it, in our hands. Okay, we have been using it. So these kinds of scales can be used. Even sometimes in our labs we have a bigger ones, 1 meter scales. Okay, using such scales we can actually find out these distances. The moderate distance, for example, what is my height? That's a moderate size. Okay, something that can be measured using the available instruments, using the normal instruments like meter scales. That is a moderate distance. Like, what is the dimension of the room? That can be found out using a normal scale. So it's again a moderate distance. What is the let's say dimension of the road? For example, there is a road side by over here. What is the dimension of that road? That can be easily found out using a meter scale. What is the height of a building? Okay, it's let's say 10 floors building. So we can easily find out, isn't it? Using a normal meter scale. That's not a big deal, isn't it? So such things can be easily found out. Okay, then what we can say, any other animals, like you are told to find out what is the length of a snake. Sometimes we see on a Discovery Channel, they measure the length of the anaconda or some other kind of a snake, isn't it? How do they do that? They use a meter scales, normal scales. That's it. So these are all moderate distances, and for measuring such moderate distances we just require normal scales. That's it, nothing else. Okay, so that's what works over here, and that's pretty easy also. We can do it very easily. That's not a big problem for us, because that's moderate, that's average, that's something that is in our hands actually. Okay, yes, so that is not a big problem. The problem arises over here as we move up. Okay, over here we have done this, that's pretty easy. Okay, this is the big problem over here. Very small distances, let's talk about that first. Very small distances. What do we mean by very small distances? Like, as I told you, the size of the paper, isn't it? Thickness of that paper, the thickness of the hairs, isn't it? Or maybe, what about the size of a virus? What about the size of the blood cells? Or any kind of a cells, isn't it? What about that? Aren't they small? Don't you think they are very small? Can you see them through your naked eyes? Definitely no, isn't it? It's very difficult to see such viruses, such cells through our naked eyes. What do we need? We need powerful microscopes, isn't it? Okay, so let's talk about them. How do we exactly do it? First of all, starting with that size of a paper and the size of the hair, So for such things we use instruments like the vernier caliper, the micrometer screw gauge and the traveling microscope. Okay, the vernier caliper, the micrometer screw gauge or the traveling microscopes. Using these kinds of instruments we can actually measure sizes of the order of 10 raised to minus 5 to 10 raised to minus 6 meters. Okay, we can measure what? We can measure distances of the order of 10 raised to minus 5 to 10 raised to minus 6 meters. That's a huge, that's immensely small. Okay, 10 raised to minus 6 meters, okay, to 10 raised to minus 5 meters. Okay, so that's a pretty small distance, minus 6, minus 5, imagine. Okay, so we can measure these small distances using such instruments like the vernier caliper, the micrometer screw gauge and the traveling microscope. Definitely each of these instruments operate on a different principles. Okay, but they are not that hard to operate, that they are not that difficult to operate, they are very easy. Okay, so for such distances we can use these equipments. But when you go to even smaller sizes like the size of a virus, size of a blood cell, size of any other cell, now there comes a problem. These instruments are not capable of measuring that size. Okay, for such purposes now we require what we call as the microscopes. The powerful microscopes is what we need here to observe such blood cells or maybe some other kinds of cells or some viruses. We require powerful microscopes. Okay, and that is what we do. We use the powerful microscopes, isn't it? And we observe these cells. Okay, generally what we do is there is a light, there is an illumination that is used. Okay, and using that actually we observe that cells or observe those small objects, and we get very high resolution pictures of those very small objects. Okay, so again we can do that. Okay, that is one of the ways of looking at such a small objects and finding out their dimensions. Okay, that is a best way. Okay, but there is a even bigger problem. There is a even smaller problem. Okay, that means when we come to even smaller sizes than the size of the cell or size of a virus, like the size of the atom, the size of the molecule, the size of the nucleus, size of electron. Okay, when you go to such problems, now there is a bigger problem that arises. Now your powerful microscopes are not going to work here. How would they work over here? Okay, how would they work? Because they work on the principles of light, they work on the principles of illuminations. Okay, they use light as their equipment. Okay, all these microscopes, they use light. Okay, but light is a wave. Light behaves like a wave. Okay, light has a wave like properties, and every wave has got some wavelength. So that's why every microscope has got some limit of resolution. Okay, this wavelength of the wave, that causes the problem over here, that stands as an obstacle over here. Okay, because over here every microscope or any microscope can only resolve those objects which are of the order of wavelength of light. Okay, any microscope can only resolve those objects which are of the order of wavelength of light, nothing else. Okay, if the object is smaller than the wavelength of light, it cannot resolve it. The microscope will fail to resolve it. Okay, for example, if the wavelength of light is, let's say 10 raised to minus 7 meters, for example. Okay, let's say if the wavelength of light is 10 raised to minus 7 meters, for example, and if the size of the object is 10 raised to minus 8 meter, for example. Okay, this is the wavelength denoted by lambda. Okay, and this is, let's say, the size, let's say x. Okay, so over here you can see 10 raised to minus 8 is smaller than 10 raised to minus 7. That means x is smaller than lambda. So in that case, the microscope will not be able to get a picture of this object. It is not going to resolve that object. That is the problem. Okay, because every microscope has got a limit of resolution, and the limit of resolution is nothing but the wavelength of light which is used as its source. Okay, so that is the problem over here. Okay, now the question is what to do, because viruses can be seen, okay, with some powerful microscopes, cells can be seen with some powerful microscopes, but not the atoms, not the molecules. Okay, we can't see smaller objects like these, atoms and molecules. Okay, so what to do? The answer to this is nothing but the electron microscopes. Okay, the electron microscopes. Over here, electron microscope is a very sophisticated, okay, kind of a, you can say, a very difficult instrument to operate over here. Okay, only experts can handle it. Okay, because microscopes are something that we generally operate from our, let's say, 11th standard or 12th standard in a biology class. Okay, or you can say biology lab. Okay, we do that generally, but these instruments are not to be handled by any 11th or 12th standard student. Okay, or any other kind of a student. Okay, it has to be handled by some experts from this field. Okay, he should have that knowledge of how to operate it. So these are quite sophisticated instruments, the electron microscopes. Okay, so using these instruments we can actually observe very small objects. Okay, very small objects. We can even picturize the atoms, the molecules. Okay, we can go to that deep level. Okay, in fact, to be precise, electron microscopes which can measure the size of 0.6 into 10 raised to minus 10 meters. Okay, electrons microscopes which can measure the sizes of the order of 0.6 into 10 raised to minus 10 meter. Such microscopes have been already built, and these instruments are able to produce high resolution images of very small objects like these. Okay, you can imagine. Okay, you can imagine how small these sizes are. And these instruments, okay, electron microscopes, can actually get a picture of such small objects. Okay, there are other techniques like spectroscopy, using which also we can picturize, okay, what do the small objects look like. Okay, we can picturize using the spectroscopic techniques. Okay, then recently there is one more technology called as tunneling microscopy. Okay, tunneling microscopy is also one of the great achievements, using which we can get very high resolution pictures of microscopic objects like these. Okay, so that is again one of the options, okay, which we can have for measuring very small distances. Okay, so what are the options? Vernier caliper, micrometer, screw gauge, and the traveling microscope. These were our first choice, but then when we move to even smaller objects like the cells, then we have to go to powerful microscopes. But to see even smaller objects, we have to use the electron microscopy, or maybe the spectroscopic instruments, or maybe the tunneling microscopy. Okay, so we have to use all these instruments over here. Okay, so that's what we generally do. Okay, so this is how we measure this very small distances. Now we go to the last one, very large distances. How do we do that? How do we exactly measure the very large distances? Okay, now what do we mean first of all by the very large distances? The answer is very simple. Very large. Okay, very large, like the size of the earth, for example, or maybe the distance from the earth to the moon. Okay, the distance from the earth to the sun. Okay, or maybe the distance from the earth to any star. Okay, distance from the stars, that's a big thing. Maybe the size of the sun, size of the moon, that is also a big number, isn't it? So definitely these distances cannot be measured using normal scales, isn't it? Can we? No, we can't. Definitely we can't, isn't it? So what do we do? Can we use the scales? Definitely we can't. So what do we do? Can we just walk and go there? No, we can't. So what do we do? So there are techniques. There are some techniques, there are some methods used for that. Okay, there are some techniques. Now, nowadays, if you see, with all the technology that we have, we can have lots of things, actually, lots of equipments, which can be used. But previously, okay, in the previous years, in the early ages, I would say, early ages of the science, okay, what did the people do to find out the distances between the planets? Have you ever wondered how did those people found out the distances? Okay, see, nowadays I will tell you what we do. Nowadays people use lasers. Okay, they use laser. Okay, they use laser to find out the distance from the moon to the earth or to some other planet. Okay, laser is recently developed, but previously there was no laser. What did the people do to find out such long distances? So there is a method actually called as the parallax. Okay, there is a method called as the parallax. Using that method itself, we could find out very long distances. Okay, very long distances we could find out. Okay, so this is what we do. We use the parallax method. Okay, we use the parallax, we used to use it, okay, for a very long time. Now also we use it, but for a very long time this method has been very handy to the human being. Okay, using this we have been able to find out the distances between the stars. We have been able to find out the size of the planets. Okay, lots of things we could do using this method. Okay, so this is a very handy method. Okay, in this same playlist you will find out the parallax method video on that also, how exactly we can use that method. Everything has been explained, you can just check that, okay, in the same playlist. Okay, so over here parallax is the method for us to find out the large distances. Okay, but yes, that was quite old method, but nowadays also it is used. But at the same time there are other methods also developed, like nowadays, just now I said, we can use the lasers also. Okay, using the very highly intense, okay, very high intensity lasers, very powerful lasers, we can actually find out such a long distances. Okay, that also can be done. There is one more way actually, but it's a little bit calculation based, little bit theory based. Okay, but yes, practicals are also involved, but lots of calculations are also involved. This is Doppler effect. Okay, this is called as a Doppler effect. So over here, using the Doppler effect, okay, people can actually find out the long distances, very, very, very long distances between the stars, galaxies, okay, etc. So all these things are being done actually in science. People are doing that. People in astronomy actually do all these things. Okay, people in astronomy are actually concerned with this. Very large distances. Okay, what are the distances between the stars, the galaxies? Okay, everything. People are actually concerned with this. Okay, and they are actually doing it. They are actually finding this out. They are actually looking for these distances, and they are actually using these instruments, these methods. Okay, so it's actually very exciting. Okay, I mean, these distances seem to be little difficult methods, but it's really fun also when you go to do it. Parallax method itself is very fun method actually. You will understand that in the coming videos. Okay, so this is what we do for measuring distances of different kinds. Okay, I hope this is clear. If not, you can ask me in the comment sections. Okay, I hope everything is clear. Okay, I mean, I hope there is no doubt. If you have any doubts, you can definitely ask me in the comment section. Okay, I will definitely answer to you. Okay, so thank you so much for watching. Thank you so much for listening. Have a nice day. See you. Bye bye.